So here we have a proton traveling with a velocity of 2.7 times 10 to the 6 meters per second due east. And it experiences a magnetic force that has a maximum magnitude of 7.7 times 10 to the negative 14 newtons and direction of due south. We're going to be finding the magnitude and direction of the magnetic field causing the force. And if the field is up, then it's going to be a positive number, and if it's down, we're going to be getting a negative number. So here I just have the little map of north, south, east, west, and we see that the velocity is going east, the magnetic force is going down, south, and so we're going to be using the formula for magnetic force on a moving charge, and that is going to give us that the magnetic force, FB, is going to equal the absolute value of the charge, Q, times the velocity or speed times the magnetic field magnitude and times sine of theta. So we have the magnetic force, which is going to be in newtons. We have the charge, which is going to be in coulombs. The speed or velocity, which is going to be in meters per second. The magnetic field magnitude, which is going to be in teslas. And we have sine theta, and theta is going to be in degrees Celsius. Or not, oh my gosh, just degrees. And so to start, we can first we know that it's the maximum magnitude, so our theta is going to equal 90 degrees, and sine of 90 degrees is 1, so we can just take out sine theta because it's going to equal 1. So we get that FB is going to equal the absolute value of Q times the speed and the magnetic field magnitude. And we can rearrange this so that the magnetic field magnitude is equal to the magnetic force divided by the charge and the speed. And so we know that the charge downward is going to be 7.7 times 10 to the negative 14 newtons, and that is going to be over the charge, and the charge is going to be of a proton, and the charge of a proton is going to be 1.60 times 10 to the negative 19 coulombs. And that's going to be the charge of a proton. And then we can plug that in here. And then we're going to multiply that by the speed. Oh my goodness, 2.7 meters per second. And that is going to give us B equals about 0.178, and these units are all going to go to Tesla, and that's going to be our units for the magnitude of the magnetic field. And so using our left to right, we know that, and because it's the maximum magnitude and it's 90 degrees, we know that it's going to be perpendicular. So it's going to go down into the paper. So it's going to be positive. So we just get B equals 0.178 Teslas. Thank you.